welcome back to our channel. And for today's video, I will be discussing all about right triangles and similarities in right triangles. So, let's get started. Woo! Hey, now let's get on with our first theorem. Theorem 75. The right triangle similarity theorem. So in this theorem, it states that in any right triangle, the altitude to the hypotenuse divides the triangle into two right triangles which are similar to each other and to the given triangle. So, with this figure right here, we can deduct that. So as it says in the statement or in the theorem, that our altitude right here, this line here BD, is the line that divides our whole right triangle here into two more right triangles. So if we were to write that, but first let me get my marker. You got our marker right here. So now we can draw the figure of these two right triangles from the big right triangle or triangle ABC. So if we were to write that, draw that as two different similar triangles. Two similar triangles. It will look like this. Now, it will look like that. So see if you divide this into two. Yeah, it's what it looked like. So, naming these two triangles. Since our altitude here is BD, same goes with these two triangles. So, if we were to write that, it would be A, since this came from this part and we have the letter A here. This would be B and D. Same with the other side. Only since this half came from this part, which is triangle BDC, we would write that as C. Now, since these two triangles were converted from this big triangle right here, it is similar to each other and to this triangle too. So if you were to write a proportionality statement about this, it would be known as triangle ABD is similar to triangle ABC. So, as I was saying before, that this triangle here is similar to this triangle here too. Same goes with triangle BDC. So let's just write that there. ABC. Now, these two triangles, they are also similar to each other. So, let's write that there too. Triangle ABD. Yes, my writing sucks. Is similar to triangle BDC. And that's it. Woo! Hi. So before we move on to our theorem 76, which is the Pythagorean Theorem, let us first discuss the corollary under theorem 75, which is the Geometric Mean Theorem. Dun, dun. Okay, so geometric theorem means that in a right triangle, the altitude to the hypotenuse is the geometric mean of the segments into which it divides the hypotenuse, and each of the legs is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So, did you get all that? I'm just kidding. So, with the wave of my hand, I hereby summon an equation. Wah! Okay, now we have our problem right here. So, our problem wants us to find the values of CD, AC, and BC. Now, before we start, let us recall on how to get the geometric mean of a value. So, to get the geometric mean or otherwise known as the average of a set of numbers. We get the sum of the numbers and then divide them by how many numbers we have. Now let us start. Let's start with finding CD. So let's write CD here. Now, in finding CD, so CD is the altitude to line AB that formed AD and BD. So the values we have available here are 4 and 9. So we're going to use that. So recalling on the Geometric Mean Theorem, since we're talking about means here, we will multiply this. We'll multiply 4 by 9. And then when we multiply them, so that equals to 36. Now 36, okay, let's ponder on this little detail here. Now see that our CD here has a square, so we can't leave that as it is because CD has a square and we're not finding the CD squared, we're finding CD. So what we have to do is get the square root of both sides, so we cancel that here, so that leaves us with the square root of 36, which is 6. So now we found the value of our CD, which is 6, so let's write down there. So CD is 6. Now moving on to AC, since we're done with CD, so let's just check that there. And we have our 6 right here, which is the value of our CD. Now, time to get AC. So AC is the altitude to BC, which is this here, that formed line AD and AB. So we can use, let's just write AC squared over here first, and we can use AD and line AB, the values of these two lines. So the values of these two lines are AD, which is 4, and AB. Now note that AB is 4 plus 9 because we're using the whole line here, so we would have to add these two numbers in order to get the whole measurement of line AB. So we would have to write this as 9 plus 4, and 9 plus 4 is equal to 13, and then we multiply that by themselves, so that would, okay, well, we won't be able to get the square root of this, can we? So what we have to do is to break it up into its radical form. So we have 4 here, and if we get the square root of 4 or get the multiples of 4, 2 is a perfect square, so we can use that as a number outside our radical sign, and we can keep our 13 inside the radical side. So now we have the value of AC. Oh, let's move that there. Now we have found the value of our AC here. Now let's just write that here. So AC is 2 square root of 13. Okay, now that we have found the values of our AC and CD, let's check it out over here. All we have left is to find BC. Now, as we see in our triangle, BC is the altitude to AC that form line BD and AB. So we can use the values of BD and AB to find our BC. Let's just write BC squared over here, and then BD, AB, and there. So now we'll write their numerical values here, which is 9, and as we did before, AB, right? So AB is the sum of line AD and DB. So like we did in the previous problem, we add 4 by 9, which we get 13, 9 and 13. Oop. There we go. Let's write BC squared here. Now, like before, the number 9 here, if we get its multiples, which is 3 times 3, 3 is a perfect square. So we can write that. We can rewrite that in its radical form. So 3 square root of 13. And now we got our BC here. Now it's complete. So let's write down BC in its place. We can erase this right here. There we go. Let's write 3 square root of 13. And now we have completed our missing values. And that basically sums up on solving using the Geometric Mean Theorem. See, the Geometric Mean Theorem wasn't that much of a problem for us because it was really easy, because all you needed to do was multiply, and then divide. That's all. Now on to the next theorem and the last one for my vlog. Let's go on to the Pythagorean Theorem. Okay, so now before we start with all the process on how to use the Pythagorean Theorem on a problem, let us first discuss the history of the Pythagorean Theorem. Okay, so the Pythagorean Theorem was the earliest theorems to be known in ancient civilization. So this theorem is famous because it was named after a Greek mathematician and philosopher, Pythagoras, who was believed to have first taught this theorem to his students. So yeah, so the Pythagorean Theorem was named after Pythagoras. Bruh. Yeah, big difference there. So let's get on with how to use the Pythagorean Theorem. Woo! Okay, so now the Pythagorean Theorem. So in the theorem, it states that the square of the hypotenuse of a right triangle is equal to the sum of the square of the other two sides. So that's how we got c squared is equal to a squared plus b squared, because c squared is what represents our hypotenuse and a and b represent our other sides. Now to use this in a problem, which I will be giving right here with my magic marker in 1, 2, 3. Now we got our problem right here. Now with the application of the Pythagorean Theorem, let us start. But disclaimer, I'm using my blue marker now because my black one ran out of ink, so we don't want that going on in our video, don't we? So let's write our formula here for reference. So our c squared plus our c squared is equal to our sides, which is represented by a plus b, and then we can name these two as a and b here, but note that this can be interchangeable, meaning that our 7 centimeters can be b and our 24 can be a. Now since our c is represented by hypotenuse, you can write c there. So let's get on with the solving now. So let's write c squared here, and then our a, which is 7, so we'll write 7 squared there, and then our b, 24 squared. Now this value of these two are 49 plus 576. Now adding these two together, we get 625. Now we can't leave our c as c squared now, can we? So we'll have to get the square root of both sides, so we'll cancel the 2 there and get the square root of 625. So our c is now equal to 25. So that is the value of our hypotenuse. So let's write 25 centimeters. You can't forget that, or else all of our effort here will go to waste since we don't have our centimeter here. So that's it. That is how we solve finding the hypotenuse using the Pythagorean theorem. Okay, so that concludes our video. Thank you so much everyone for watching, and I hope that you've learned something from my video. And I just want to say that this has been really helpful for me too, because I have mastered the lessons that I've taught to you, and I hope that what I've taught you, you can use in the near future or whatever, any point in your life. I don't care. Just kidding. So, bottom line is, thank you so much everyone for watching, and please check out my classmates' videos, which are in the channel right here. You can just click on our channel, and please subscribe, please like this video, and don't forget to comment. I really want to know what you think of my vlog here, and I hope that you enjoyed. So thank you very much for watching, and I hope I see you guys soon.